Greetings and welcome. This is Dr. V.D.Y. Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be doing the important problems in the tutorial question bank supplied with the Engineering Mechanics course. The fourth module of the Engineering Mechanics course, which is Kinetics of the Body and the Work Energy Equation. In this module, we are going to do the important problems in the tutorial question bank. So, we will be solving number of problems in the concept of D'Alembert's principle, where the inertia force will be involved into the system. So, first we will be considering the kinetic problem, which is given as a bullet of mass 81 grams moving with a velocity of 300 meters per second is fired into a log of wood and it penetrates to a depth of 10 centimeters. If you understand this, let us say there is a log of wood here and a bullet is being fired. A bullet is being fired into this log of wood. So what happens? Because of the velocity with which the bullet is traveling, the velocity is given as 300 meters per second. This log of wood is resisting the movement and the bullet penetrates to a depth of 10 centimeters. It penetrates to a depth of 10 centimeters. Maybe the log of wood, the size is more, but the bullet's capacity is only, it will be penetrating into the log of wood until 10 centimeters. If the bullet moving with same velocity, right? So, same bullet is being fired, same revolver, same pistol, and the bullet is being fired. If the bullet moving with same velocity were fired into a similar piece of wood 5 centimeter thick, okay? Now, what we are considering? Only 5 centimeter thick of wood is being considered. The same wood, but the length is only, the depth is only 5 centimeters. 5 centimeter thick wood is considered. With what velocity it emerges? Isn't it? The capacity of the bullet to penetrate into the same log of wood is 10 centimeters. But we are firing the bullet to only 5 centimeters thickness log of wood or 5 centimeter thickness wood. Then what happens? It still has capacity. Once it reaches the starting point of the wood, after traveling 5 centimeters, it will be still having capacity to travel furthermore. Isn't it? So, the velocity won't stop at that 5 centimeter. So, the question asked is, with what velocity the bullet emerges, comes out of the wood. Find also the force of resistance, assuming to be uniform. So, there are two questions that is being asked. The first question is completely related to the kinematics problem, but the second question, which is find also the force of resistance. That means we need to identify the force with which the log of wood is resisting the movement of the bullet is to be calculated. So, after understanding this problem, using the figure, let us start to solve the problem here. The given mass of bullet is 81 grams. That means it is having a weight of or mass of 0.081 kg. And the initial velocity with which the bullet is moving is 300 meters per second. We can consider it as u. Then the distance to which the bullet travels when the log of wood, the whole big log of wood is considered, and the distance to which the bullet can travel is given as 10 centimeters, that is 0.1 meters. We have the equation v square minus u square equal to 2as as the equation of motion. From this, if we simplify this equation, we will be obtaining the acceleration a as minus 4,50,000 meters per second square. This minus symbol indicates that the acceleration is decreasing. That means this is a retarding acceleration, retardation or deceleration. So the ultimate value of this acceleration is, or the deceleration is, 4,50,000 meters per second square. And in the second case, what is happening? We are firing the same bullet into a 5 centimeter thick wood. So when S is equal to 5 centimeter, that is equal to 0.05 meter, then if we apply the same equation of motion of v square minus u square equal to 2as, we will be obtaining the velocity of the bullet with which it is emerging out. Okay, so initial velocity is 300 and final velocity we need to identify, and the distance to which the bullet is traveling is 5 centimeters, which is 0.05 meters, and acceleration just now we have calculated it as minus 4,50,000 meters per second square. When you substitute this, you will get the value of velocity, emerging velocity, as 212.132 meters per second. Now, the resistance offered is given as F is equal to ma, that is equal to mass of the bullet is 0.081 kg, and the acceleration or retardation is minus 45,000. So when you solve this, you will be obtaining minus 36450 newtons, which is a retarding force. So these are the answers for the question asked. Now let us go for second problem. This problem is related to the movement of the lift. So a lift has an upward acceleration of 1.225 meters per second square, and there are three questions that are being asked. Question A is, what pressure will a man weighing 500 Newton exert on the floor of the lift? So here the question is asked about the pressure, and a man is in the lift. Okay, man is in the lift and he is standing on the floor. So ultimately, when the lift is present here and man is standing here, that means the total weight which is acted downwards, the pressure will be ultimately seen as the tension in the string. The pressure, that the weight and the man that is exerted onto the lift, it will be seen as the tension in the string. So the question represent here to find the tension in the lift because of the 500 Newton man that is inside the lift. And the second question is, what pressure would he exert if the lift had an acceleration of 1.225 meter per second square downwards? Okay, so the lift, when the lift is moving downwards with an acceleration of 1.225 meter per second square, then what would be the value of tension? That is the second question. And coming to third question, what upward acceleration would cause his weight to exert a pressure of 600 newtons? Nothing but the tension is 600 newtons, and what would be the acceleration when this kind of situation happens? When the upward acceleration, that means lift will be moving upwards. Now coming to the first answer, lift moving upwards, we can take the tension in the string T and upward movement with weight of the lift along with the person is 500 newtons. The acceleration given is 1.225 meters per second square. And let T be the tension in the cable, which is equal to the pressure exerted by a man on the floor of the lift. Now the ultimate equation we do have is the change in the force, that is resultant force T minus W is equal to MA. When we apply the equation, solve the equation, T is equal to W plus MA, that is equal to 500 plus 50.97 into 1.225. So the answer of the tension would be 562.436 newtons, right? So as you can observe here, the weight of the lift along with the person is 500 newtons, but the tension T is higher than the weight. So the obviously the lift will be moving upwards. Now as the second case, lift moving downwards. When the lift is moving downwards, the movement acceleration will be in the downward direction. So we can consider W minus T is equal to MA, right? When the lift is moving downwards, the weight will be higher than the tension. So from this we can write T is equal to W minus MA. which will be written as 500 minus 50.97 into 1.225. So when we solve this, we will get the value as 437.56 newtons. Then coming to third one, lift moving upwards and pressure exerted by man is 600 newtons. That is, T is equal to 600 newtons. Now we have T minus W is equal to MA. Which when we solve this, we will be obtaining 600 minus 500 is equal to 50.97 into A. So ultimately when we solve this, A can be obtained as 1.962 meters per second square. Okay, so this is the acceleration when the man exerts a pressure of 600. Nothing but the tension is 600 newtons. Then what would be the acceleration when the lift is moving upwards? So this is how the problem of motion of the lift will be considered. Now let us do the problem on D'Alembert's principle, which is involved in the equilibrium condition of the bodies in the system. So the question given is, a 750 Newton crate rests on a 500 Newton cart. The coefficient of friction between the crate and the cart is 0.3. Here you can observe this is the crate and this is the cart, and there is the coefficient of friction between the crate and the cart. Okay, that means there is a friction that is prevailing between the two bodies. And between cart and the road, that means this contact point, cart and the road, again it is having the friction, is given as 0.2. If the cart is to be pulled by a force P, this is the force with which the cart is being pulled. Cart is being pulled, nothing but the force P is being applied to the cart, such that the crate does not slip. Crate does not slip. That means this movement, both combined, the movement should be obtained both combinedly. Determine the maximum allowable magnitude of P and the corresponding acceleration of cart. So in this system, there are two objects, two bodies. One is the crate and another is the cart, and the force is being applied onto the cart. So we need to see that there is no slippage of the crate from the cart. So let A be the acceleration when the crate is about to slip. Okay, so A be the acceleration when the crate is about to slip. If we see the free body diagram of this particular crate, then we can observe that this object, this crate, is trying to move towards left side. Why? As this force is being applied here, the total object will be moving in this direction. Total object will be moving in this direction. When we can say that this acceleration is happening in the left hand side direction. So we can say the implementation of inertia force will be towards the right hand side. Implementation of inertia force is towards the right hand side. Okay, so that would be MA. Now coming to the application of friction. Here the case is different. Here the case should be considered as the movement of the object. Friction should always be considered in the negative direction or opposite direction to the movement of the object. So what we can take, the movement of the object is happening in the right hand side direction. Why this is considered in the right hand side direction movement? Because here observe, the crate and the cart is being pulled by force P. That means this object is trying to move towards left side. Then in which direction this object is trying to move? As this is trying to move towards left side, this object will try to move towards right side. That means it will try to slip down towards the right side direction. Hence, the friction will be acting in the opposite direction to the movement of the object. So, the friction will be acting in this direction. That's why the friction direction is shown towards left side. Coming to the inertia force. What does inertia force represent here? Inertia force is the force which will have the direction opposite to the acceleration of the object or the movement. Opposite to the acceleration of the object's movement. So, in which direction the acceleration is happening? When you consider the movement of total object or total body, the object is traveling in the left side direction. So, the acceleration happens in the left side direction. That's the reason the inertia force will be considered towards the right side direction. That's how the free body diagram is drawn here. So, when you apply the conditions of equilibrium, that is sigma Fy is equal to 0, we will be obtaining, there are two vertical forces N1 and W1. So, this can be written as N1 is equal to W1, that is equal to 750 newtons. Also, we have mu is equal to F by N. So, F1 is equal to mu1 N1. When you substitute the values, you will get the value of F1 as 225 newtons. When considering the sigma Fx is equal to 0, that is all the horizontal forces is equal to 0, you will be obtaining the value of acceleration as 2.943 meter per second square. So, this acceleration value is the acceleration with which the object will try to move. Now, consider the dynamic equilibrium of crate and cart as a single body. Now, what we are doing, we are combining both the crate and cart. Why? Because there is no restriction or no supports or no external force that are being acted onto the crate. So, we are combining both the crate and cart when we are considering the system as whole. Then, the total weight of the system would be 1250 newtons, the 750 and 500 cart. So, the free body diagram for the total crate and cart combined will be like this. And when we apply the conditions of equilibrium for this free body, the total body is considered, sigma Fy is equal to 0 gives N2 is equal to 1250 newtons, and also F2 is equal to mu2 N2, that is the coefficient of friction is equal to F by N. From this we can obtain the value of F2 as 250 newtons. Then sigma Fx is equal to 0, which is the summation of all the horizontal forces in the system, which gives the value of P as 625 newtons. So, 625 newtons is the force that is required, maximum allowable force that is required for the crate not to slip when moving. Now, let us do another problem on the inertia force, the D'Alembert's principle. The problem given is a mass of 2.5 kg projected with a speed of 4 meters per second up an inclined plane, inclined at 15 degrees with the horizontal. After traveling 1.2 meters, the mass comes to rest. Determine the coefficient of friction. Okay, so this is the figure. The figure is not given in the problem, but according to the details that are given in the problem, we have drawn the figure here. Here, what is happening? There is an inclined surface or inclined plane on which the object is being pushed up or projected. We can say the object is being projected using what initial velocity? Initial velocity of 4 meters per second. So, after traveling 1.2 meters, that means from here to here, 1.2 meters, it has come to rest. That means the final velocity of the system or the block is V is equal to 0. Now, they are asking us to find the coefficient of friction. That means the value of mu. When it is termed as the coefficient of friction present in the system, that means there is at the contact surface of the block and or the mass and the plane, there is friction prevailing. Friction prevailing. So, now we need to apply the free body diagram and we need to show the direction of friction as well as the inertia force for this particular system. As the object or mass is moving in right side direction, we can directly say that the friction is acting towards left side direction, and when the friction is acting towards left side direction or any direction, the normal reaction will be towards the object. Then coming to the inertia force, what is happening here? As we have discussed in the section when we were discussing about the deceleration of the object and inertia force, this mass is decelerating. That means in this direction there is negative acceleration. That gives us the idea that acceleration is towards left hand side. Acceleration is towards left hand side. That's the reason the inertia force will be towards the right hand side. That means up the plane. That is how the free body diagram is drawn. And the weight of the mass or the weight of the object W it is acting vertically downwards. So this would be a inclined force for the system as we are considering the inclined plane condition. So that would be converted or resolved into two mutually perpendicular components. One is along the plane and other is normal to the plane. So this is how the free body diagram will be shown. Now coming to the mass, which is given as 2.5 kg. From this we can obtain the value of W as 24.525 newtons. And if we apply the equation of motion V square minus U square equal to 2as and substitute the values, we do have final velocity and initial velocity and the distance to which the object is moving. So from this ultimately we can get the value of acceleration as minus 6.67 meters per second square. This represents it is decelerating. Then if we apply the condition of equilibrium of sigma fx is equal to 0, we will be getting the value of F, which is the frictional force, as 10.325 newtons. You can observe the equation. We are taking all the horizontal force, or we can say along the plane forces, and equating it to 0. When simplification is done, we will be obtaining the value of F as 10.325 Newton. Also, sigma Fy is equal to 0. That is, all the normal to the plane components is equal to 0. That we will be obtaining as n minus W cos 15 is equal to 0. So, from this, the value of n, normal reaction, can be obtained as 23.69 newtons. Hence, mu can be obtained as F by n. Coefficient of friction mu equation is F by n. When you substitute the values, you will be getting the value of coefficient of friction as 0.436. So this is the coefficient of friction value for the given system. Now let us do a problem on D'Alembert's principle for the connected bodies here. The problem given is two weights 800 Newton and 200 Newton are connected by a thread and they move along a rough horizontal plane under the action of a force of 400 Newton applied to the 800 Newton weight as shown in figure. So according to the figure, the force of 400 Newton is being applied to 800 Newton weight. The coefficient of friction between the sliding surface of the weights and the plane is 0.3. Using D'Alembert's principle, determine the acceleration of the weight and tension in the thread. Right? So we are going to involve the D'Alembert's principle, nothing but we are going to involve the inertia force into the system and we are going to calculate the tension and the acceleration of the system. So first we are going to consider the dynamic equilibrium of 200 Newton weight. That means we are going to draw the free body diagram for this particular case. We have seen the concept here, the 200 Newton weight. As the force is being applied in the right hand side direction, we can say that the acceleration is happening in this direction. So the inertia force is towards left side. Also at this contact point, the frictional force, object is moving in right side direction. So the frictional force will be acting towards left side, which is considered as F1. And N1 is the normal reaction. So from this, if we apply sigma Fy is equal to 0, we will be getting N1 is equal to 200 newtons. Then we have mu is equal to F by N. From this, we can obtain the value of F1 as 60 newtons. If we apply sigma Fx is equal to 0, all the horizontal forces is equal to 0, then minus F1 plus T minus Ma is equal to 0. If we substitute the values, we will be getting the equation T is equal to 200 by 9.81 A plus 60. Take it as equation 1. Now consider dynamic equilibrium of 800 Newton weight. So when we consider the dynamic equilibrium of 800 Newton weight, the free body diagram is drawn here like this. Similarly, the case as the 800 Newton weight is moving towards the right side, the inertia force will be towards left side. Also, the frictional force will be towards left side. And the force that is being acted here and the tension that is being acted is shown like this. So for this system, For this free body diagram, let us apply the condition of equilibrium. Sigma Fy is equal to 0, which will be implying the value of N2 as 800. And we have F2 is equal to mu N2, that will be obtained as 0.3 into 800, that is equal to 240 newtons. So when we apply the sigma Fx is equal to 0, all the horizontal component forces is equal to 0, we will be getting the equation as T is equal to 800 by 9.81 A minus 400 plus 240. Take it as equation 2. Solving the both equations, equation 1 and 2, we will be obtaining the values of acceleration as 0.981 meters per second square and the value of tension as 80 newtons. Now coming to the connected bodies which are involved in the pulleys here. The problem given is determine the tension in the string and acceleration of blocks A and B weighing 1500 newtons and 500 newtons connected by an inextensible string as shown in figure. Assume pulleys are frictionless and weightless. So as per the given figure, what we are doing is consider the dynamic equilibrium of 1500 Newton block. Here, if you consider the free body diagram, the 1500 Newton weight is acting vertically downwards and the tension value which is attached here is taken as 2T. Why it is happening? If you consider, there are two strings that are attached for the single string which is wound 2 times. We will be considering the single string that is wound 2 times for the object. So when we consider the object of 1500 newtons and the string as a single entity, then what happens? Generally, it will be treated as two strings. Tension T and tension T here acting away from the object and the weight of the object acting downwards. Okay, so both combined T, it will be considered as 2T. So the tension value here would be 2T. You need to concentrate, not all the situations will be having the 2T value. Here, as per the given situation, this block which is having a bar type of this thing here, it is being acted with two strings. It is being attached with two strings here. Each having the total system will have the same tension as this is attached. The total two bodies are connected using a single string. But as per the given situation, we can see here that this object is being tied with two strings individually considered. So the tensions would be double. And as we can see, the object is moving downwards, the inertia force is taken in the upward direction. Now, if we take sigma Fy is equal to 0 for this situation, we will be getting 2T plus 1500 by 9.81 A is equal to 1500, which is equation 1. Now, consider the dynamic equilibrium of 500 Newton block. Now, in this case, what we are doing, this is attached with a single string here. Okay, this body is attached with a single string here, but the movement of this object, movement of this 500 Newton object will be double the acceleration. Why? Because as this 1500 Newton block is wound to double the string here, one unit of acceleration to which this 1500 Newton comes downwards, 2 units of acceleration, this 500 Newton will move upwards. Why? Because that acceleration is dragging this 500 Newton block in twice manner. So the acceleration will be double for the system or double for the 500 Newton block. There is a difference here for the regular things which we have considered, that is all the blocks will be having the same acceleration. There is a slight difference here. The difference will be considered because the way in which this 1500 Newton block is being utilized to tie using this string. So with this, the acceleration would be double. So tension will be single, but the acceleration will be in a double manner. And as this weight is trying to move upwards, this 1500 Newton comes downwards, so 500 Newton goes upwards. So the inertia force will be towards downward direction. So the equation that we will be obtaining is sigma Fy is equal to 0. which is given as T minus 500 by 9.81 into 2A is equal to 500. Take this equation as equation 2. Solving this equation 1 and 2, we will be obtaining the values of accelerations and tension as 1.401 meter per second square and 642.89 newtons respectively. Let us see the problem on work done. The problem given is a man wishes to move wooden box of 1 meter cube to a distance of 5 meters with the least amount of work. If the block weighs 1 kilonewton and the coefficient of friction is 0.3, find whether he should tip it or slide it. So this is the problem given, where in first case the object is having weight of 1 kilonewton and the object is being applied with a force horizontally of P with respect to the movement, and the frictional force, as this object is moving towards right side, frictional force will be acting towards left side, and this is the normal reaction L. And in second case, what happens is this same box, it is being tipped in the right hand clockwise direction. So while tipping, what is happening is the center of gravity of this object is being raised to a distance of h. Actually, the center of gravity's position is here at the center at a distance of 0.5 meters. But what is happening? For tipping purpose, what we are doing is we are raising this center of gravity, to a height of h. So tipping is making in that fashion, and the direct pushing of the object is with the application of force P onto the object or wooden box. So first we are considering the work done in sliding. In this work done in sliding, we can see the value of N, which is equal to W, that is equal to 1 kilonewton, and we have got the coefficient of friction mu is equal to F by N, which will give the value of friction F as 0.3 into 1, that is equal to 0.3 kilonewton. When applied force P is equal to F, that is equal to 0.3 kilonewton, if we calculate work done, it is given as P into S, that is 0.3 into 5, that is equal to 1.5 kilonewton meter, or we can say it as 1.5 kilojoules. Now, when the work done in tipping, in one tipping, the center of gravity of box is to be raised to the height of h is equal to 1 by root 2 minus 0.5, that is equal to 0.207 meters. Therefore, work done in one tipping is equal to W into h. That can be written as 1 into 0.207, that is 0.207 kilojoules. To move a distance of 5 meters, 5 tippings are required. So, overall, therefore, work done for 5 tippings is 5 into 0.207, that gives 1.035 kilojoules. So, with this we can say that as the low energy is consumed or needed while tipping, the box should be tipped as low energy is needed for tipping. Now, let us do a problem on friction and power. An engine and a train having a load of 300 tons are moving on a straight horizontal track with a uniform speed of 48 km per hour. If the frictional resistance is 68 Newton per ton, calculate the power exerted by the engine. If the train moves up a gradient of 1 in 200, what additional power is required to maintain the speed? So, as per the given data, the mass of engine and train is M is equal to 300 tons. So, that gives 300 into 1000 kg. So, weight can be represented as W is equal to 300 into 1000 into 9.81 newtons. And the uniform speed U is given as 48 kilometers per hour. If we convert that into meters per second, we will be obtaining it as 13.34 meters per second. Then the frictional resistance is given as 68 newtons per ton. So total frictional resistance can be obtained as Fr is equal to 68 into 300, that is equal to 20400 newtons. Now consider the case 1 where the force exerted by the train or by the engine is equal to the frictional resistance. If we overcome the frictional resistance, then the object or train will move. So that force exerted can be represented as Fr is equal to 20400 Newton. Then power exerted by the engine, the equation for the power exerted by the engine, that is power is equal to force into velocity. So the value is 20400 into 13.34. So it results in 272136 watts. So it can also be written as 272.136 kilowatt. And in case 2, the gradient of track is 1 in 200. That means for every 1 meter that is going to be increased for 200 meter length, the increase in the inclination would be 1. So sin theta can be obtained as 1 by 200. And the force exerted is obtained as F is equal to Fr plus W sin theta. That is equal to 20400 plus 300 into 1000 into 9.81 into 1 by 200. So this results in 35115 newtons. And power exerted by engine can be obtained as F into U, that is force into velocity. So that gives us as 35115 into 13.34. So the value would be 468434.1 watts. Or we can write it as 468.434 kilowatts. Hence, the additional power required would be 468.434 minus 272.136. So the value additional power required is 196.298 kilowatts. Now let us do another problem on this work energy equation. A small block starts from rest at point A and slides down the inclined plane as shown in figure. What distance along the horizontal plane will it travel before coming to rest? That is the first question. Then the coefficient of kinetic friction between the block and either plane is 0.3. Assume that the initial velocity with which it starts to move along BC is of the same magnitude as that gained in sliding from A to B. So the points given here are A, B and C, and AB is the inclined plane and BC is the horizontal plane. And the inclination is given in terms of sides of the triangle as 3 and 4. If we draw the free body diagram of the first case, here we can observe that as the body is sliding down, the frictional force will be shown in the upward direction and the normal reaction value is shown, and the weight of the object, it will be resolved into mutually perpendicular components. So from this we can write N1 is equal to W cos theta and F1 is equal to mu N, which will give mu W cos theta. And applying work energy principle for this case, R into S is equal to 1 by 2 W by G V square minus U square. When you substitute the values of forces here, minus F1 plus W sin theta into 5. Here there are two forces that are involved in the system. So we are considering the forces minus F1, which is acting in negative direction, plus W sin theta, which is acting in positive direction, into 5 is the distance to which the object is traveling, is equal to 1 by 2 W by G VB square minus 0. Now further simplification, we will be obtaining the value of VB as 5.943 meters per second. Now consider the horizontal plane and the object's movement in horizontal plane. If we take it as N2 is equal to W, the value of F2 would be 0.3 into W, that is equal to 0.3 watts. 0.3 W. Hence, applying work energy equation, R into S is equal to 1 by 2 W by G V square minus U square, we can get the value as minus F2 into S, that is equal to 1 by 2 into W by G VC square minus VB square. And when we substitute all the values given here, we will obtain the distance to which the object moves after sliding down the plane is S is equal to 6 meters. Now let us do a problem on the connected bodies here. Two blocks of A 200 Newton and B 240 Newton are connected as shown in figure. When the motion begins, the block B is 1 meter above the floor. Assuming the pulley to be frictionless and weightless, determine the velocity of block A when the block B touches the floor. And second one, how far the block A will move up the plane. This is the free body diagram of the given system. Here we are directly applying two bodies as it is, and the directions in which the forces are acting are being considered. Now for applying work energy equation for case 1, here we are going to get R into S is equal to 1 by 2 W by G V square minus U square, and substituting the values of the forces that are involved in the system, that is 3 forces involved, minus 200 sine 30 minus F plus 240 into 1 meter is the distance travelled, is equal to 1 by 2 200 by 9.81 V square minus 0 plus 1 by 2 240 by 9.81 V square minus 0. So this summation of the kinetic energy, that is change in kinetic energy, we are applying at a time for the both objects. So first part of this summation is for body 1 and second part of the summation is for body 2. Also, n is equal to 200 cos 30. From the figure we can obtain this. So F is equal to 0.2 into 200 cos 30, that is equal to 34.64 newtons. Therefore, V is equal to 2.168 meters per second. Now applying the work energy equation for body A alone. We are going to get minus 200 sine 30 minus F into S is equal to 1 by 2 into 200 by 9.81 into 0 minus V square. So from this, if we simplify this equation, we will be obtaining the value of the distance S as 0.35 meters. Now another problem on this work done. A block of mass 5 kg resting on a 30 degrees inclined plane is released. The block, after travelling a distance of 0.5 meter along the inclined plane, hits a spring of stiffness 15 Newton per centimeter. Find the maximum compression of the spring. Assume coefficient of friction between block and the inclined plane is 0.2. So this is the figure which we can draw from the given data. There is an inclined plane which is inclined at 30 degrees to the horizontal, and the block which is released there from the above, it is traveling 0.5 meters and then it touches the spring. When traveling in this direction and touches the spring here, initial uncompressed distance is like this. After touching or after colliding with the spring contracts to a distance of x here. So this is what given in the figure. Find maximum compression of the spring, assume the coefficient of friction. So from this figure, the free body diagram, we can get the value of F is equal to mu n, that is equal to 0.2 into mg cos 30, which can be obtained as 0.2 into 5 into 9.81 into 0.866, that is equal to 8.495 Newton. And K is equal to 15 Newton per centimeters, that is equal to 1500 Newton per meter. Let X be the compression of spring. Now applying work energy method, we can get mg sin 30 minus F into 0.5 plus X plus minus 1 by 2 Kx square. This minus is taken because the work is done onto the spring, is equal to 1 by 2 into m into V square minus U square. So further simplifying this, we will be obtaining the value of x. Solving the quadratic equation, we will be obtaining the value of x as 0.115 meters. So that is the compression to which the spring will be undergoing. With this, we have done with the important questions in the tutorial question bank in module 4. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.